morning. Oh, good morning, ladies and gentlemen. That's recording that started.
Stop it.
Good morning, ladies and gentlemen. Good morning.
Good morning.
Good morning, ladies and gentlemen. The class recording has started. Good morning, ladies and gentlemen.
All right, ladies and gentlemen. Recording is really about to start now.
I said that
so,
already.
Thank you. I appreciate you taking that up. So.
Has it started yet?
Oh, it has. Yes, the red light is blinking
cool.
down there.
Hi.
All right. Yesterday, we talked about a brief history of the development of the periodic table, and we said that the person that is most generally credited for the development of the periodic table is named what? Mendeleev, Dmitry Mendeleev, right? What is the big idea? What is the big concept that Mendeleev used when setting up that periodic table? Patterns. What do we call that pattern?
Oh, the most. The echo?
Periodic law, right? That as we look at the properties, of these elements, we see that there is a pattern that repeats itself, that there are similarities in the properties of certain elements, and that if you group those elements together, you'll figure out that certain elements go together in certain columns. Those columns, the masses get bigger as we go down those columns, and we see that repeating pattern over and over again. How did Mendeleev know that he was right in his discovery of the periodic law? Say again? Okay, had a specific order. What did he do with that specific order? The blank spaces, right? And the blank spaces were what? Hypotheses, predictions, right? About elements that we hadn't discovered yet. And what happened when we discovered those elements? They fit the pattern, right? They fit those predictions, okay? Yeah, yes, the echoes, yes. And so now, if we have a pattern that is repeating, we can use that pattern to make predictions. Those predictions come out to be right. Obviously, that we're on to that pattern. We have something there, okay? All right. The periodic table that Mendeleev put out there, this one that you're looking at on the screen right now, is obviously not the same periodic table that we use today. Did we talk about tellurium and iodine on the periodic table?
Yes.
Okay, so we talked about the idea that on our modern periodic table, that if we look on our modern periodic table, right? If you look at the average atomic masses of tellurium and iodine, tellurium actually is heavier than iodine is. But when we have it set up, iodine is after tellurium on the periodic table. And Mendeleev even knew this. Even though he set his elements up according to atomic mass, he knew to flip iodine and tellurium, not because he knew anything about those elements, but because he knew the pattern, right? That when he looked at the pattern, iodine fit better with fluorine, chlorine, and bromine than it did with other elements. And so, we pick it up right from here, right? When you look at the periodic table now, what is it organized by? Or what is the order that the elements go in? They go by atomic number, right? They go by atomic number. Why didn't Mendeleev organize them by atomic number? Okay. When we talk about Mendeleev, we're talking about the 1860s. We don't discover the idea of subatomic particles until about the 1890s. Mendeleev didn't know about protons. He didn't know about the nucleus. He didn't know about electrons. All he knew was that how these atoms compared to each other. It took us into the 20th century with a guy named Henry Moseley, who figured out a way for us to know the positive charge that existed on each nucleus. Rutherford knew, what experiment did Rutherford do? Gold foil, right? From gold foil experiment, we know that there is a nucleus, and we know that it's positive charge, but Rutherford didn't know that every nucleus of every atom was different from the nucleus of all the other atoms. It took Henry Moseley to do that, then we arranged that periodic table by atomic number instead of by atomic mass. And then finally, Glenn Seaborg, he put the periodic table in the form that you most know it in by moving of the intertransition metals, and we'll talk a little bit about more about that today. Okay. All right, good there? Okay. Let's talk about some of the information that the periodic table will give us. All right, so we just talked about that Mendeleev's periodic table was arranged according to increasing atomic mass, but that isn't how we arrange the periodic table today, right? How do we arrange that periodic table? Atomic number. And Mendeleev didn't do that, right? Because he didn't know about the nucleus. He didn't know about protons. You too. And today, we arrange the periodic table by increasing atomic number, right? What does atomic number tell us about the end? Number of protons, number of electrons, okay? All right, good here? When we look at each square of the periodic table, generally speaking, most periodic tables are going to give you at least 4 pieces of information. Some periodic tables will give you more. The one on the board over there gives us a ton more information than just these 4, but these are the 4 important ones. So, what's letter A representing in each square?
Atomic number.
That's the atomic number, right?
Atomic number.
Letter B is going to be what? Atomic symbol, elemental symbol, whatever. Both of them are the same. Okay. Yeah, and use those 2 terms interchangeably. What's important to remember about elemental symbols, especially 2-letter elemental symbols? Say again? The name goes with it. No. When we're writing these symbols, right? Nora,
Uppercase, lowercase.
what's important when you have 2-letter symbols?
Oh, this is what I got marked off for on my quiz last time. One has to be the first one has to be uppercase and the second one has to be lowercase.
Good. First one's capital, right? Second one's lowercase, and we have those 2-letter symbols, okay? If it's a single-letter symbol, it's always uppercase, okay? All right, letter C is your elemental name. And then, what is D representing? Average atomic mass. What else could letter D represent? The molar mass, right? We said that those 2, the average atomic mass and the molar mass, are the same numerically, right? But we're talking about a different number of atoms. All right, good there? Yes? No? No? Okay. Rows and columns. We call each row on the periodic table a period. We label those periods. First, are we good with the difference between rows and columns?
Yes.
Okay. Rows go which way? Horizontally, right? And columns will go. So no, we're not okay with rows and columns, but rows are horizontal, columns are vertical. Okay. Each row on the periodic table we call a period, and we label those periods with a number that is equal to the principal quantum number. Ooh, there's a blast from the past. It might not show it up on there, but like we would talk about like here, here. So this one has it on the side over here that we would label each row that the first period. So the first period only has 2 elements in it, just hydrogen and helium, because it's the first row. They're split up, but that's the first row. The row that starts with lithium would be the second period. The row that starts with rubidium would be the 5th period. It just goes down from the top in numeric order. All right, columns. Columns we either call a group or a family. Those two terms mean the same thing. We can use them interchangeably.
Like atomic symbol.
And atomic symbol, yes. Different periodic tables will number the groups differently. The most modern, up-to-date version just takes the groups and numbers them from left to right, starting at number 1 and going to number 18. So, come on. Nope. So if you come here, right, just across the top, this is the group number, right? Hydrogen tops group 1, beryllium tops group 2, etc., etc., etc. Okay? Just 1 to 18 from left to right. However, you'll see on some periodic tables, and the one that's hanging up in the room has both versions of this system. Sometimes they will use an A-B system, that the tall rows on the periodic table, group 1, group 2, group 13, 14, and 15, 16, 17, 18, you'll see are followed with A's. But then the short section of the periodic table, groups 3 through 12, have sort of like B's after them. That's just an older way of representing those columns, but some periodic tables will still do that. So hydrogen's group, sometimes we call it group 1, but sometimes we'll call it group 1A. It doesn't mean anything differently, it's just a different way of numbering them. No, group 4 is something different. Yeah, sorry, those ones on the bottom are something different. We'll talk about those in a little bit. All right, good? Okay. Nope. There we go. All right, so we're gonna have to use our brains a little bit here and remember some things that we talked about in the past. All right, I'm going to have us write some electron configurations. Ooh. It's something we're going to use to introduce the next section. Okay. So, no, it's not. So, but we need some of that. No, we need some of that information to do that. Okay. So here, let's write just like it says in the slide. Come on. Come on. All right. We are going to write some electron configurations. Electron configuration. Okay. And Nita, like you said, that's the one with the what? It's the one with the exponents, okay? So the first one that was listed was lithium. So we first have to determine how many electrons lithium has, right? So we look on the periodic table, we find out that lithium has how many electrons? 3. It's lithium's atomic number. All right, electron configurations work off of this same chart. What's the first orbital that gets filled? 1s. It's at the bottom, right? How many electrons can that 1s orbital hold? Okay, we represent it like that. But we still have one more electron to place, so we go up the chart, come up to 2s. How many electrons will be in that 2s orbital? 1 in this case, right? Because there's only 1 left. Okay. All right. So the next one I asked you to do was sodium. Okay. We can, if we want to, shorten this up using our noble gases configuration, right? So which noble gas would we start sodium with?
Like,
Neon, all
It
right?
gives me a chance to look.
Okay.
Wait, how do you know where neon is?
Well,
Like, without having to draw it out.
well, Bella, how many electrons are we talking about if we start this with neon? 10, because that's neon's atomic number. Okay. So, you'll get better at this as you go along, but each line on this chart represents how many electrons, or 2. So, 2, 4, 6, 8, 10. Okay? So that accounts for the first 10 electrons. So where would we go next? 3s. How many electrons will there be in that 3s orbital?
One.
Just one. The next electron configuration that I had written down there was potassium. Okay? So we find potassium on the periodic table. How many electrons are we talking about? 19. So we can do this first. Okay? Without the capital R, just lowercase r. And that argon accounts for how many electrons? 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. What's the next? 4s. And how many electrons are in that 4s?
One.
Just one.
Are we gonna be able to use the periodic table on the final?
Yeah, absolutely.
Now, you have to memorize all these.
Gotta remember them all.
We don't need your sarcasm.
Elemental.
All right.
Symbol.
All right. I'll go through these ones pretty quick so we can get to the gist of what we're doing here, okay? Could have. Yes, I could have put helium in place for this one right here. It just writing helium versus writing 1s2 really doesn't save us a whole lot of time. So
I think we
I
should.
wrote FL instead of F.
okay. There's my electron configurations for fluorine, chlorine, and bromine. Okay. Good. All of the blue ones are in the same group. Which group are all of the blue electron configurations in? 1. Group 1. All of the pink ones are also in the same group. Which group are they in? 17. What are we seeing about electron configurations of elements that are in the same group? They end in the same sort of pattern, right? Is that a coincidence? Probably not, right? We'll learn more about why when we talk about bonding, but know that these elements that are in the same group have similar arrangements of electrons around them. Not the same arrangements, right? We're talking about different principal energy levels farther from the nucleus, but similar. 2s2, 2p5 is similar to 3s2, 3p5, is similar to 4s2, 4p5, right? What do we know about elements in the same group? What did Mendeleev know about elements in the same group? Why did he put them in the same group? They were alike in some way. They have similar properties, and those properties are determined by these electron configurations. Okay? So, with that being said, elements in the same group have similar chemical properties. And that's why those chemical properties repeat in a predictable pattern when they're arranged by atomic number, because you end up with the same or the similar arrangement of electrons in the outside part of that atom. Right? That's how periodic law happens. So atomic theory, structure of an atom, location of electrons around the nucleus, et cetera, et cetera, et cetera, atomic theory explains periodic law. Yes, no, maybe? Does that, if I say that statement, does that make sense?
Say it again.
Okay, so in the last unit we talked about atomic theory, right? Structure of an atom, where electrons go, all that stuff, right? Atomic theory, electron configurations, explains periodic law. Laws tell us what is happening. Theories tell us why it's happening, right? Why is it happening? It has to do with the arrangement of electrons and where those electrons go. All right, good? Okay. All right. Okay. Let's talk about some of the main sections of the periodic table. We're going to talk basically about 4 main sections of the periodic table. We're going to talk about metals, nonmetals, transition metals, and metalloids. I'm going to show you how to, no, we're going to color. We're not yet. All right, good with these 4? Okay. I'll wait patiently.
Yes.
No.
I'll wait patiently.
Okay. Okay.
I wonder if you can hear my fingers tapping.
Wait, I can't see.
Did we not fill that in?
Do we have to write inner transition metals? Did you write that?
Sorry, did we not fill out that part up at the top of the back page?
No,
Sorry.
we didn't.
Apologize. This is the top of the back page. So. Alright, notice that it says similar, not the same, similar. Joe's good. Everybody else good?
I'm good. No. What fonts are the categories of the note?
Your name down this
One nice.
And
All right. So, let's go here. Okay. And let's start off with metals. First, metals are on the far left-hand side of the periodic table. Okay, here's what I'm going to do. I figured this morning, after my second period class, that it would be easier if you had all of these elemental names in there, but obviously I didn't do that for you in the original one. So let me do this here.
Or you're just gonna put it directly over here.
I didn't think about that, but I don't know. They're 2 pictures, so I was just gonna do stuff up here on the board. Okay. All right. So as far as metals go, the dividing line is going to happen somewhere along here. So metals include. No, you don't have to write the letters in. So, all right, metals are going to include this, 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 and this. I mean, you can fill it in if you want to, but for the sake of time, if you just want to outline it, that's okay. All right, so these ones that I have outlined in red here, these are our metals. So along the edge over here, aluminum, gallium, tin, bismuth, livermorium. Bismuth.
wait a second.
Columns are families.
Why
Okay.
did
Hydrogen is not a metal.
I messed up?
Oh.
That's what I didn't know.
Hydrogen, because of the fact that it only has 1 electron, sometimes behaves like a metal, but more often than not, it behaves like a non-metal. Because it has 1 and only 1 electron, it doesn't exactly follow the rules. Okay. Yeah, it's like a rule breaker. All right. This section, which is sort of a subset of your metals, so I'll use pink for this one. Okay. This section right through here, the short section of the periodic table, okay, those 10 columns right there, we refer to as the transition metals.
Oh, seriously?
Say again?
I didn't know columns long going back.
Oh, it does. It does. My bad. My bad. Yeah, sorry about
For
that.
transition, so transition metals are metals.
Transition metals are metals. All transition metals are metals, but not all metals are transition metals.
Okay, I just want to make sure because I did that one time, so.
All right. So then here.
Oh, seriously?
Sorry. Huh?
Wait, you know
What?
what's so
Unlucky, everybody. We'll finish this up on Monday. Hey, have a great long weekend, everybody. I'll see you on Monday.
Thank you.